Hello, class. I am having you do this over YouTube because my son was homesick today, but I would like to walk you through their last topic before the spring break. We'll pick it up again when you return, but hopefully we won't spend an awful lot of time going back over it. But before we start, I would like you to make sure that you're paired up with the, and if the chairs are not organized properly, please do so. You will all need headphones, or either that or you can use the closed captioning on the YouTube channel if you need to. But the first thing I'd like you to do right now is to open your student journals, which I asked you to bring to class. If you didn't bring them, I guess you're going to need to go get them. So if you need to go get them, please pause and tell the substitute that you're going to need to do that, and then come back. Okay, well, I would like you to open your student journal to section 5.6. And in 5.6, there is an exploration called Exploration 1. And this is what I would like you to do. Now, one thing I forgot to ask you is to get a handout from the substitute. So that's going to be your guide for today. So again, if you need to, please pause this, pause the YouTube channel right now, and make sure that you have a copy of that sheet. If the substitute doesn't know where it is, you can just tell them it's on that little shelf to the, where I usually sit to my left, and it's sitting in one of those little slots on the top of that. And it's marked section 5.6. Okay, so let's go ahead and get started. You're going to be working together, and in Exploration 1, you're going to see A, B, C, and D. A, B, and C, and D both have two functions. And what you're going to do in your calculator, or if you must take one of your computers out and go to Desmos, and I want you to graph, looking at A, I want you to graph f of x equals 4x plus 3, and then I want you to graph g of x equals x minus 3 all over 4. And I would like you to do that with all four of those, A, B, C, and D, and I want you to look at the graphs and see what pattern you're seeing in the results. So I'm going to ask you to pause right now and do those graphs and discuss what you guys think is going on. So I'm going to pause right now, and we'll get back to you as soon as you're done with that. Okay, what you should have noticed is on A, you had two lines that crossed. And that may not have looked too interesting until you got to B. On B, what you might have noticed is that you had two shapes that were a reflection of each other. And when I say a reflection, what I want you to think about is the line y equals x. The line y equals x is a diagonal line that goes from the lower left to the upper right. If you draw that line in and think of it as being a mirror, you would see that these two functions are mirror images of each other, reflecting around that y equals x line. Think about that and consider the graph of C, and finally the graph of D, which looks like two portions of a circle that are reflected around each other. So what I'd like you to do is what this is an introduction of what we call inverse functions. Inverse functions graphically are two functions that form mirror image of each other, where the line y equals x, the diagonal line that goes from the lower left all the way to the upper right, it would be the mirror. Okay, so with that, I'd like you to move to exploration 2. And in exploration 2, they're asking you to see if you can't create the reflection of the function that's drawn in. How would we do that? Well, let me just give you a quick clue. Look for any point on the line for A, and one point might be -1, -3. So if you see that point, -1, -3, go ahead and draw it in your book. Now that's -1, -3. What you need to do is just switch the two numbers to get a point on the reflected line. So if that's -1, -3, think of -3, -3, -1. And that will be the position of the reflected line. So basically, to get any point on the reflected line, all we do is switch the x coordinate with the y coordinate, and that will give us the mirror image. Okay, it looks like I messed up on that one. It's not -1, -3. It is, each box is 2. I know that drives some of you guys crazy, and it just drove me crazy. It should be -2, -6. So the reflected point should be -6, -2. And if you draw that dot in, you will see that it's on the other side of that line. Of course, I wish I had a picture of this with me, but I don't. I only have this worksheet that I made yesterday. Look at another graph. Another example would be on C. If you see the point, -4, -8, plot the point -8, -4, and you're going to get that reflected point. And then you're just going to do what you can to see if you can't trace in the rest of the reflected graph. Go ahead and give that a shot and see if you can create the inverse function. I'm going to pause now and have you do that on your own, or try to do that on your own. Okay, whether or not I lost you, I don't know. But at this point, what I'd like to do is just show you a little bit of the nuts and bolts of what you're going to be expected to be able to do. The example 1 is pretty simple. What they're trying to do is they're saying write a formula for the input of the function. So the idea is that we usually input. If you look at number 1, let me get my question number 1. Typically, what we do is we input on the x value. So this is the x value. So the question, what they're asking for, is to find. Is to create an equation for x. So, in other words, we want to be able to find out what the based on what the output is, what the input would have been. So again, input is x. So what I'm going to do is I'm going to solve for x. I have y equals x minus 2. Let me just substitute the f of x for the y. I add 2 to both sides. And now I get the equation, flipping it, of x equals y plus 2. Oops, sorry for the pause. Okay, so I add 2 to both sides, and so flipping it around, I get x equals y plus 2. So essentially what that means is now I can put an output value in and see what the input value would have been in the original equation. So in this case, it says the output value was 2. Well, if the output value was 2 in the original equation, that means that the input value must have been equal to 4. So let's go see what that means. Well, go to the original equation, and it says that if I use an input value of 4, I should get an output value f of x of 2. Well, did that work? And the answer is, yep, it did work. Okay, I will do one more, and these are supposed to be the ones that you were doing, but I'm going to have you do the ones that do the one that I was supposed to do, the example one on the top. But let's do this one really quickly. Again, basically what I'm going to do is solve for x. So, and just so you know, I'm just not to mislead you, but the technique that we're going to be using in a moment is going to help us find what's called the inverse function. So bear with me for a moment. Let's solve this for x squared. Again, what I'm going to do is I'm going to replace the f of x with y equals 2x squared. Divide both sides by 2. If I go too fast, please go ahead and replay it. But now I've got x squared equals y over 2. And then I'm going to square root both sides. Now when I square root both sides, I still have to do the old plus or minus thing again. Plus or minus square root of y over 2. And then what we do is we're going to plug in the output value 2. Well, 2 over 2 it's 1. So the final answer here is going to be x equals plus or minus 1. 2 answers. I'm going to save you a moment of time here on a Thursday morning, and I'm going to cross out number 3 and ask you to go up to example 1. And example 1, I'm going to rewrite as y equals 2x plus 3. Now I'm going to ask you to pause this and take a moment, you and your partner, and see if you can't solve for the value x. All right, so pause for a moment, and when you come back, I'll show you the solution. Okay, welcome back. Subtract 3 from both sides. Y minus 3 equals 2x. Divide both sides by 2. X equals y minus 3 divided by 2. And in this case, they asked you to put a 7 in there for the output value. Negative 7 minus 3 is equal to negative 10 over 2, and therefore our input value was negative 5. So basically we're just looking at this as reversing the process. We're trying to, usually we plug in a value for x and get y. What we're looking at here is, okay, if I have y, what was the value that was plugged in for x? I know that sounds strange, but just bear with me because we're going to use this technique in the next example. So next page, example 2, it says find the inverse of this function. Well, believe it or not, we're going to do the exact same, we're going to do the same thing we were just doing, but to do the inverse function, what we're going to do, I'm going to do the method 2 first. To do method 2, what we're going to do is start with the basic function, y equals 3x minus 1. To find the inverse of this function, what I'm going to do is I'm going to switch the x and the y. So what does that mean? It means instead of y equals 3x minus 1, I'm going to write x equals 3y minus 1. Notice all I did was switch the x and the y term. Now I solve for now I solve for y. Now this should look pretty similar to what we were just doing. So let me show you what that looks like. So I'm going to go x equals 3y. Let me copy it one more time. I'm going to add 1 to both sides. And now I get 3y equals x plus 1. And then I divide both sides by 3. So y, in this case, is going to be x plus 1 over 3. Now, it's not easy in this form to recognize that this is the inverse function. So what we're going to do is to give it a different name. If the original function was named f of x, we'll just give this one a different name and call it g of x. So the inverse function g of x equals x plus 1 over 3. If you remember the work we did at the beginning of the day, at the beginning of the period, these two graphs, if you graphed y equals 3x minus 1, and then you graphed g of x equals x plus 1 over 3, you would find that they were graphs that were reflections over the y equals x line. Let's go to the method 1 that we did here. The inverse function is also, it also does the opposite of what this function does. And if you look at this function here, what it does is it takes an input value, multiplies it by 3, and then subtracts 1. So one of the other ways to produce the inverse function is to do the opposite of those things in reverse order. So the original order was multiply by 3 and then subtract 1. So starting from the right side, what we're going to do is the opposite. So we're going to take the x, and instead of subtracting 1, we're going to say x plus 1. And then instead of multiplying by 3, we're going to divide by 3. So the other way to get this is to look at the input value, see what's being done to it, and then reverse the process. Do the opposite from right to left. So that may not be a popular thing, but let's go ahead and use that for the here you go portion of this. If we're going to use that method for this one, it says, okay, f of x equals 2 times x. So what's that? So there's only one thing being done. We're multiplying by 2. So let's undo that. That means that g of x is going to be x, not times 2, but divided by 2. So this is one way to get the inverse function. The other way to get the inverse function is to simply swap the y and the x. So instead of y equals 2x, what we'll do is we'll say x equals 2y, and then we'll solve for y. So y equals x over 2. And again, we want to distinguish this from any other y. We'll just call it g of x equals x over 2. Well, guess what? There it is, right? So both processes seem to work fine. You get to choose. And lucky you, huh? Anyway, so let me go ahead and move this over. Why is that circle doing that? I guess I'm going to try to get rid of it. Okay. Clearly, I don't know how this dang thing works sometimes. Okay, so let's do this method 1 and method 2. So number 5. Number 5, what's the first thing we do is look at the x. The first thing that happens is it gets negative. Let's say multiplied by negative 1. That's our step 1. And then step 2 is add 1. Okay, so let's do this in reverse. To do that in reverse, we're going to say subtract 1. So we're going to take x, subtract 1, and then going from right to left, we multiply by negative 1. And that's the whole thing by negative 1, by the way. Okay. So I would imagine that you guys probably don't like that process, so let's go ahead and do it the easier way, where you go y equals negative x plus 1. Maybe some of you like that. And then we're just going to switch the x value with the y value and solve for y. So we get x equals negative y plus 1. Subtract 1 from both sides. Negative y equals x minus 1. And now we have to multiply both sides by negative 1 to make the y positive. y equals negative x minus 1. And again, we're going to give that a new name to distinguish it from f of x. We'll call it g of x equals negative x minus 1. Okay, well, hopefully I haven't lost you yet, but I would like to take a moment and have you see if you could do number 6. So if you can pause for a moment, and you can use either process to do this. Okay, this is what I've got so far. I rewrote this with a y. I added 2 to both sides. And now I need to get this 1/3 y to turn it into a 1y. The way to do that would be to multiply both sides by 3. So 3's cancel. Y equals 3x plus 6. So that will be the inverse function, and we'll give it a different name, g of x, to distinguish it from f of x. So if you were fortunate enough to get that right, good for you. Okay, so now that we covered the basics of this, I'm hoping that some of you may be able to help each other out on this one. I know it looks strange at first, but once you've done it a couple of times, it'll start to make a little bit more sense, and we'll be hitting on this a little bit more later on. Right now, what I'd like you to do is to go on to the Big Idea site, and let's go at what I'd like you to do is just to do a few practice problems of this, of a similar to the ones that we're just doing here. And this is going to be CW 5.6, and once you've completed that, then I'm done with you. So for today, I know that's not an awful lot, but I think it's enough to bring you into the break. So let me go into it right now. I'll say goodbye to you for the break, but I'd like you right now to open up the classwork 5.6 and make that happen. So for now, though, take care, and I'll see you in a few weeks.